In video unveiling AI agents, the intelligent automation tools. We've now covered what AI agents are and the environments they exist within. But have you ever wondered about the inner workings of these fascinating entities? Like what actually goes on inside an AI agent's mind? Well, wonder no more. Today, we're going to pull back the curtain and look at how AI agents think, process information, make decisions, and interact with the world around them. So stay tuned. You won't want to miss this. First up, let's dive deep into the core components of an AI agent. Picture this. You have a little robot vacuum cleaning your house. That little guy is an AI agent out in the real world trying to navigate and understand its. But how does it do that? Well, it starts with sensors. These are the eyes, ears, and even the wheels of the robot that gather information about the environment. Sensors can collect visual data from cameras, sound from microphones, or movement and location from gyroscopes and GPS. This raw data is then fed into the perception module. Here, the data is cleaned, organized, and interpreted, so the agent can actually understand what's going on. Think of it like the robot's brain processing what it sees and hears. But wait, there's more. There's also the knowledge base. This is like the robot's memory bank filled with all sorts of useful information, like where the furniture is, where it's been told not to go, and maybe even what kind of dirt it's found under the couch. All this information helps the agent make decisions. So what are those pesky decision-making engines all about? Well, they're like the control center of the agent. They take in the information from the perception module and knowledge base and figure out what the agent should do next. For instance, if the robot sees a new rug it hasn't seen before, it would send out feelers to check the texture, color, and pattern, and add that information to its knowledge base. Then when it comes across that same rug again, the decision-making engine can use the stored information to decide whether to clean it or not. And don't forget about actuators. These are the agent's way of interacting with the world. Back to our robot vacuum. Its actuators are its motors and wheels that allow it to move around, and maybe even some greepers to pick up that dirty laundry. The action module is responsible for translating the decisions made by the decision-making engine into actions that the actuators can understand. And finally, we have memory. Just like us humans, AI agents can have short-term memory to remember what it is currently doing and long-term memory to store information about past experiences. This can come in handy when the agent needs to recall something it learned earlier or figure out why it is doing what it is doing right now. Okay, cool. Now we know the basic components, but how do they work together? Let's see. First, the perception module gathers data from the sensors. For example, if you ask a voice assistant on your phone, "What's the weather like today?" it would hear the question, process the sound waves, and understand what you're asking. Then the decision-making engine takes over. It uses information from the perception module and the knowledge base to figure out what to do. Maybe it checks the weather forecast it got earlier and puts together a response. Finally, the action module sends the response back through the actuators, which in this case is your phone's speaker. And voila, you have yourself a functioning AI agent. Now let's talk about the different types of architectures that these components can take. A single agent architecture is pretty straightforward. It's basically one agent that handles everything from perception to action. Think of it like a one-person team taking care of a small task. On the other hand, multi-agent systems involve multiple agents working together to achieve a common goal. It's like having a whole team tackling a big project. For instance, self-driving cars use a multi-agent system where different agents handle things like lane keeping, speed control, and pedestrian detection. Then there's the Retrieval-Augmented Generation architecture. This is where an LLM is used as the decision-making engine, and it consults external sources of information, such as databases or documents, to make more informed decisions. It's like having a super smart assistant that does research before giving you an answer. And let's not forget about learning elements. Some AI agents can learn from their experiences and improve their performance over time. This can be done through machine learning algorithms that allow the agent to adjust its behavior based on feedback, or by using reinforcement learning, which rewards the agent for good behavior and punishes it for bad behavior. It's like training a dog. Now you know the basic concepts and architectures of AI agents. Time to put that knowledge to the test. For starters, how reliable are these AI agents? Well, that depends on a lot of factors, including the quality of the data they're trained on, the algorithms they use to make decisions, and the robustness of their architecture. If one part of the system fails, it could cause the whole thing to break down. But there are ways to make AI agents more reliable, like using techniques like cross-validation to test machine learning models, or developing architectures that are fault-tolerant. Another challenge is dealing with uncertainty. After all, real life is unpredictable and messy, and sometimes AI agents just don't have all the information they need to make a perfect decision. In cases like these, it's important for agents to be able to express how sure or unsure they are about their decisions. This can be done using techniques like Bayesian inference or Monte Carlo simulations. Finally, there's the issue of fairness and bias. AI agents are only as good as the data they retrained on, and that data can reflect the biases that exist in the real world. It's important to be aware of these biases and take steps to mitigate them, like using techniques like adversarial training to make agents more robust against them. So how do we measure the performance of an AI agent? Well, that depends on what you want the agent to do. For instance, if it's a game-playing agent, you might measure its performance based on how many games it wins. Or if it's an autonomous vehicle, safety and efficiency would be key metrics. But no matter what, it's important to use a variety of metrics to get a complete picture of how well an agent is performing. As you can see, designing and building AI agents is a complex and multifaceted challenge. But the good news is that it is also an incredibly exciting frontier in the world of artificial intelligence. With the right tools and techniques, we can create AI agents that are not only intelligent and efficient, but also reliable, fair, and adaptable to the complexities of the real world. So keep an eye on this space because who knows what the future may hold. Thanks for watching, and if you enjoyed this video, please hit the like button and subscribe for more AI content. We also have a newsletter that recaps the week's top AI news and research.